Morning, dear students. Welcome you all for the today's online session for the subject Science and Technology Section A. In our previous session, we had started with the chapter Work and Energy, a chapter from physics. We had studied about the concept of work. What is work? What are the different types of work and the derivation for work? Then we had just started with the introduction for energy. What is energy? So today we are going to continue with the different types of mechanical energy which we have to study in details. That is kinetic energy and potential energy. So before going ahead, we will just start with energy. We will have a glance at the different forms of energy and then we will start with our main topic, that is kinetic, potential energy and their expressions. So let us see what energy is. Capacity of a body to perform work is called energy. In our previous session already I have discussed with you that work and energy are interrelated with each other. For work to be done, energy is required. For energy to be spent, some amount of work has to be done. And since both are interconnected with each other, units of work and energy are the same. So SI unit of work is joule. So SI unit of energy is also joule. CGS unit of work is erg. Hence of energy is also erg. Also, we have seen the different forms of energy last time, that is mechanical energy, heat energy, light energy. See, around you, you can see this energy, you can experience these different forms of energy. The moment you get up in the morning, the first energy which comes into play is the light energy. Then your fans are working, you switch on the lights, means light energy and electrical energy. So these are the different forms of energy which you come across in your day-to-day life. Chemical energy, whatever food, whatever breakfast you have in the morning, you know food enters the stomach where you have HCl. So the food which you eat undergoes a series of different chemical reactions. So chemical energy, nuclear energy at nuclear power plants, solar energy very known to you which we get from the sun, tidal energy, energy from the sea waves. But today we are going to study the two main forms of mechanical energy, that is kinetic energy and potential energy in details. So without wasting time, we start with our first form of mechanical energy, that is kinetic energy. Before discussing what is kinetic energy, one by one we are going to see the examples and then we will derive what kinetic energy actually is. So our first example is when a moving object strikes a stationary object, the stationary object moves. Stationary means the object which is at rest, which is in rest position. So when a moving object, see you are standing in the corridors and a child comes running behind you and hits you, at least you will not fall down if the energy level of the child is not more, but you are going to be displaced from your original position. Next example is a striker hits a coin on the carom board. Now you all are undergoing a corona COVID-19 lockdown. So many of you might be playing carom. So striker which hits the coin and the coin which is at rest moves. Next is a fast cricket ball strikes the stumps. Many of you are watching cricket, so you know the fast bowler who bowls the ball, due to its speed, due to the movement of the ball, when it hits the stumps, what happens? The stumps are likely to fall down. So all these examples, what do they tell us? They tell us that due to the motion of one object, the other object which is at rest is made to move. The object which is at rest is set into motion. So what we can derive here is the movement of the object. The moving object has some energy. I give you a very good example. You are standing, you are in a rest position, and a child comes running behind you. The child who is running has energy, part or all of which it shares with the stationary object. Wholly or a part of the energy which the moving object is having, it is going to share with the object at rest, thereby putting it in motion. So energy which an object has because of its motion is called kinetic energy. So now all of you came to know what is kinetic energy. The energy which any object possesses because of movement is called kinetic energy. Next, now we are going to see the derivation for kinetic energy. Now, for deriving kinetic energy, for deriving the expression for kinetic energy, we are considering an object which is at rest position, a stationary object having some mass, small m. It moves because of an applied force. Just now I told you that the stumps are at rest. They move because of the motion of the fast ball which hits the stumps. So we will consider here an object at rest having mass m moves because of the force which is applied to it. Let its initial velocity u. Initial velocity is represented by small u. When we see the chapter laws of motion, that time you will come to know u is equal to 0. Let the applied force be capital F. The force which is applied by the moving object, let the force be capital F. This generates an acceleration in the object, and after a certain time t, the velocity of the object becomes equal to capital V, the final velocity. After the acceleration is generated in the object, the final velocity becomes small v. The displacement during this time is small s. Whatever the object has moved from its position at rest, that movement, that displacement is small s. Here the work which is done on the object is represented by W is equal to F multiplied by S. In the beginning of the chapter, you have seen the derivation, the formula for work. So here work is done on the object. The object was at rest. So that object is made to move. So work is done on the object. So here you are going to use the formula work is equal to force multiplied by displacement. Now Newton's 3 laws of motion are there. So from the 3 laws, according to the Newton's second law of motion, F is equal to m into A. Second law of motion we are going to consider here. So force is equal to mass into acceleration. Now here you are going to use the formula S is equal to ut plus half at square. Why? Because your initial velocity u is equal to 0. So in place of u, you are going to put the value 0. Anything multiplied by 0 comes out to 0 plus half at square. So you can write S is equal to, you can remove this 0 plus, what remains? Half at square. Now take this equation again. W is equal to F multiplied by S. So in place of F, you are going to substitute the value of F, that is MA multiplied by S. So in place of S, you are going to put half at square. Now here you will take half as it is M, and A, see you can see A into A is A square. Here it is already T square. So A and T is taken in the bracket, AT square. Now here by using Newton's first equation of motion, that is V is equal to U plus AT. There are 3 equations of motions. One is V is equal to U plus AT. One is V square is equal to U square plus 2AS. And one is S is equal to ut plus half at square. So we are making use of two formulae here. So here we are using, in the previous case, we have used S is equal to ut plus half at square, and here we are using V is equal to u plus at. Now V is equal to u. What is initial velocity? 0. 0 plus at. So you get V is equal to at. Now squaring both the sides. Why squaring both the sides? Because somewhere in the previous equation you want 80 square. So how you will get this 80 square? When you are going for squaring both the sides. So you get V square is equal to 80 square. Now this 80 square is V square. So if you substitute in your previous equation, how you will get? Half m, and in place of 80 square you are going to put V square. So half mv square. Now the kinetic energy which is gained by an object is the amount of work which is done on the object. See, due to the motion of the one object, the other object is set in motion. Means the kinetic energy which is gained by the other object is nothing but the work which is done on it. Hence kinetic energy, you can also show that kinetic energy is equal to work. So in place of work you can write kinetic energy is equal to whatever formula for work you have derived, that you can show as half mv square. In this way we get the derivation for kinetic energy by using Newton's laws of equations of motions. Now how you are going to apply this formula, we are going to see through a small solved example. A stone having mass of 250 grams is falling from a height. How much kinetic energy does it have at the moment when its velocity is 2 meter per second? Now stone is having mass 250 grams falling from a height. So what is mass? Mass is equal to 250 grams. What is final velocity? What they have told? How much kinetic energy does it have at the moment when its velocity is 2 meters? So final velocity V is equal to 2 meter per square, and you want kinetic energy. Now here it is in meter per square and this is given in grams. So grams you have to convert into kg. What criteria here you are going to use? 1 kg is equal to 1000 grams. This way you can convert this grams into kg. So you will get 0.25 kg. You are going to divide this by 1000. Use the formula for kinetic energy. Kinetic energy is half mv square. Half multiplied by m is 0.25 multiplied by v square, that is 2 square. So 2 and 1 2 will get cancelled. So 0.25 multiplied by remaining 2, you get 0.5. That is kinetic energy. Energy means it will be in joules. This way, whatever formula we have derived for kinetic energy, we will be deriving for potential energy. You are going to apply for solving your numerical examples. So this is one small example which we have taken. Now, after we complete kinetic energy, we begin with our next form of mechanical energy, that is potential energy. Now again, by referring some examples, we are going to find out what is potential energy. We look at our first example, that is an arrow is released from a stretched bow. Now arrow, this barn, that arrow which is released from a stretched bow. Next, water kept at a height flows through a pipe into the tap below. Water is placed at a certain height. Or example, you can take water which is stored in a dam. Next example, we can take a compressed spring is released. If you take a spring and you compress it and after some time you release it, it will hit you. It is going to hurt you. It is going to hurt your hand. So what does all these examples tell us? That somewhere this energy is stored in an object because of its specific position, because of its specific state. Such a type of energy is called as potential energy. Now see, water is kept at a height, means due to the height, due to its position, the energy is stored in water. This energy, when it flows through a pipe from the dam, now stored energy stored in the dam in the form of potential energy. When this water is allowed to flow down, it will have motion, so potential energy will get converted into kinetic energy. So we come to know what is potential energy. The energy stored in any object because of its specific state. Now you can see compressed spring, it is in a state. Okay, so state or position is called its potential energy. As we represent kinetic energy by Ke, potential energy is represented by Pe. Now we are going to derive the expression for potential energy. For potential energy, that object has to be at a certain position or in a certain state. So here we will carry an object of mass m. Every object has a certain mass. For the kinetic energy derivation also we had seen, we had taken mass small m to carry an object of mass m to a height h above the earth's surface. Now here you are going to derive this energy which is stored due to certain position of the object. So we are taking it to a certain height h above the earth's surface. A force which is equal to m multiplied by a. Now here why g is taken? Because the force which is acting here is acceleration due to gravity. So that is represented by small g. Has to be used against the direction of gravitational force. How does the gravitational force act? It acts in the downward direction. Hence, when you throw any object in the air, what happens? It reaches a certain height and then it falls again back to the earth's surface. Why this is possible? Because the earth exerts the gravitational force on all the objects. So when you are throwing something in the upward direction, you are acting against the earth's gravitational force. So here also we are carrying an object to a certain height. So you are acting against the gravitational force which is exerted by the earth. Now the amount of work done, now here to raise something to a height, you are doing some amount of work. As usual, you are going to use the formula work is equal to force into displacement. Now here in place of force, you are going to take m multiplied by g. In our previous equation, we have taken m into a. Here a and g are nothing but one and the same. Multiply by displacement. Displacement means here a certain height. So that h you are going to substitute over here. Displacement is movement. So in the previous equation, the movement was taken as small s because the object which was at rest, it was made to move by the other object which was in motion. So there we have taken the displacement as s. Here this object is raised to a certain height h. So that is also a movement. So that you are going to take displacement here as small h. Therefore, work is equal to m multiplied by g multiplied by h, that is mgh. Now, the amount of potential energy stored in the object is because of the movement of the object. See, now this object is made to reach a certain height, and due to the height, the amount of potential energy is now stored in the object. So, potential energy is equal to what? Here now W you can write as P, that is potential energy is equal to mgh. Now this is similar as we have derived for our previous form of energy, that is kinetic energy. See, there the amount of work was done on the object which was put in motion, and here the amount of work is done on the object which is raised to a certain height. So here also in place of work you can write potential energy. You will ask me why potential energy? Because Now the energy is stored in the object because of a position, because of the height. So potential energy is equal to mgh. Now displacement to the height h. To a certain height h, it causes the energy which is equal to mgh to be stored in the object. And hence the expression for potential energy is equal to mgh. So here today we have studied two formulae. One formula is for kinetic energy, that is half mv square. Kinetic energy, that is half mv square. And next we have studied the formula for potential energy, that is potential energy is equal to mgh. Now as we have seen how this formula is applied in solving a numerical example, similarly here we are going to see how potential energy is applied, how the formula for potential energy is applied in solving a numerical example. The example states 500 kg water is stored in the overhead tank. Now see, tank is overhead, means at a certain height. They have purposely mentioned the word because tank, if they only mention tank, then tank can be placed at the earth's level also, earth's surface. But they have said overhead, means due to the height, the water is already having potential energy. So 500 kg of water is stored in an overhead tank of 10 meters high building. So the height of the building is given as 10 meters. Calculate the amount of potential energy stored in the water. Now due to the height, the object is having potential energy. So what is the height? H is 10 meters. Mass is given as 500 kg. Now you can see here, height is in meter, mass is also in kg. It is not given in grams. So you can keep it in kg. You need not convert as we have done the conversion in the previous example. Now you know you have to calculate the amount of potential energy. Formula is mgh. You have the value of m, you have the value of h. We want to get the value of g. All of you know that value of acceleration due to gravity is taken uniformly as 9.8 meter per second square. Always remember, when you take in meters, then g is 9.8 meter per second square. This is uniform. This will not be provided in the question. You should know it. And when it is in centimeters, CGS unit, that time you take g as 980 centimeter per second square. Apply the formula. Potential energy is equal to m into g into h. So mass is 500, g is 9.8, multiply by h is 10. So when you multiply all this, you will get 49,000. Now again it is energy and all the units are in MK system. So your answer will be in joules. So children, here you have to take due care while solving any numerical example in the board exam or your school exams. Main thing you have to take care is, even though you do not have any marks for writing this given, you have to write the given in the answer sheet. Because once you write the given part properly, looking at it, you come to know whether you have to make any conversions of the unit. Secondly, you have to write the formula very precisely. The formula should be correct. After formula, your substitution and getting the final answer. But even if all these things are correct and your units are not written properly, then you are likely, not only likely, you will surely lose half a mark from your total marks which are allotted for the sum. So if your sum is for 2 marks, you will get 1.5 mark. If the sum is for 3 marks, you will get 2.5 marks. So always remember, even if your answer is correct, the answer is not valid without a proper unit. So you should, now here you can see in the entire sum, nowhere the unit of joule is given. So this is nothing but application of knowledge. You should know that what is the unit of energy. MK system, it is joule, and CGS system, it is erg. Now here all the units are in MK system, so my energy unit will be in joules. Here if this was grams, here also it was centimeter. then here you would have taken 980 and your answer would have been in ergs. So this is simple application of knowledge. We move on to the next part of our topic, that is transformation of energy. What do you mean by this word, transformation of energy? You know that energy exists around you in different forms. Now let us see whether this energy can be transformed from one form to the other. Before going to the actual part of transformation, we are going to see different examples and which type of energy exists in that examples. We begin with our first example, a stretched piece of rubber. Just now we have taken the example for potential energy, a compressed spring. So here also it is a stretched piece of rubber. You know rubber band. When you stretch it and then you try to beat the other person, it surely hits as compared to the rubber which is very loose, it is not stretched. You beat the other child with that rubber, it won't hit, but when you stretch and then you hit the other one, it is surely going to hit. Why? Because now the energy is stored because of the position of stretching. So potential energy. Next example is fast moving car. As soon as you see the word moving, movement, motion means kinetic energy. Next is the whistling of a cooker due to steam. You all know that cooker, when there is a whistling of cooker, which type of energy is experienced? You can hear the sound. So sound energy. Next is the crackers exploded in Diwali vacations. So you all know what type of energy is experienced when a single cracker explodes. You get to hear the sound, you get to see the light, and you all know the amount of heat rise, or the amount of heat which rises after the crackers explode. So all the three different types of energy are experienced. A fan running on electricity. In the beginning only I had taken the example. The moment you get up in the morning, the different types of energy which you experience around you. This is very sure, not only the moment when you get up, the entire night also the fans are running on. They run on electrical energy. Drawing out pieces of iron from garbage using a magnet. By using a magnet, the iron is segregated from your other garbage. Which energy? Magnetic energy. Breaking of a glass window pane because of a loud noise. So here which type of energy? Loud noise. So sound energy. So you can see the energy can be seen in different forms. So this energy can be transferred. It can be transformed from one form to the other. Energy can be transformed from one type to the another. For example, the exploding firecrackers, just now we have discussed, they convert the chemical energy stored in them. You know, inside the firecracker, the energy is present in the form of chemical energy. When they explode, the chemical energy gets converted into light, sound and heat energy. So clearly you can see the transformation. Here, different examples through this chart you will come to know. The electric lamp, it stores the electrical energy and converts into light energy. Solar cell or photoelectric cell, it converts the light energy into electrical energy. The engine or the fan, it converts your electrical energy into mechanical energy. Being staying in Virar, a very good example. When the current goes away, when the current is on, when your power supply is on, what happens? This electrical energy, due to the working of the fans and all, this electrical energy is stored by the generator into the mechanical energy. And when this current goes away, when the power supply is off, this mechanical energy is converted by your generator or small inverters in your house into the electrical energy. And then whichever devices are attached to it, they start working. So these are the different examples which will tell you, which will confirm that yes, surely energy can be transformed from one form to the other. And from these examples, we come to a very simple law, that is law of conservation of energy. Energy can neither be created nor destroyed. So, whenever our planet Earth was formed, the amount of energy which was given to the Earth's surface, that was limited. So, that energy you cannot create, new energy you cannot create in the laboratory, nor you can destroy. It can only be converted from one form to the another form, and hence the total amount of energy in your entire universe always and always remains constant. Very simple law of conservation of energy, which tells us that energy you cannot create, neither you can destroy, but you can only convert from one form to the another form, hence keeping the total amount of energy in the entire universe constant. This is the law of conservation of energy. So in our today's session, we have seen what is energy, which are the different forms of energy, the two forms of mechanical energy we have studied in details, their formulae, how to apply in solving the numerical examples, and then how energy can be transformed from one form to the other we have studied today. So in our next session, tomorrow's science 2 period I am going to use for science 1, and I am going to complete with this explanation of chapter. So our explanation will get over tomorrow. So here we stop with our today's session. So all of you keep on reading the topics which we have to cover in our next session. You are supposed to read the topics and keep your notebooks completed. Thank you, dear children.